The topic of this video are the Mars Exploration Rovers. They were called Spirit and Opportunity. First of all, I'm going to give a small overview of the mission and give you a few basic facts. Then I'm going to talk about the rovers themselves and their technical details, like the autonomous navigation system, the structure, and the instruments. Then I will go into a few things we learned from the mission and the scientific results. So, first, to the overview. The rovers were built to resemble little geologists that walk around and analyze interesting rocks they encounter. They were not able to collect rock samples. On one side, they were supposed to analyze rocks and soils on the surface for their mineral content and search for minerals that only form in the presence of liquid water. One of those is, for example, hematite. Also, iron-containing minerals were searched. Those are heavily altered by liquid water and can therefore tell us a lot about Mars' aqueous history. On the other side, the rovers were designed to find signs of physical abrasion by water on the surface of Mars. The MER landed on Mars in 2004. Opportunity landed in the Meridiani Planum and Spirit in the Joseph crater. Spirit was supposed to prove the presence of hematite in the Joseph crater. The instruments of an orbiter had sensed this mineral in there previously. By confirming the orbiter results, the rover proved the reliability of the orbiter results and found a good indicator that liquid water once existed on Mars. The planned lifespan of the rovers was 90 days. After that, the dust buildup on the solar arrays was expected to prevent the rovers from recharging. However, favorable winds cleaned the wings regularly and enabled them to work for many years, which was a really big success. So, now to the technical details. First, the structure. If you look at the predecessor of the MER, Sojourner, here on the left, which was the first steerable rover on Mars, and then at the Mars Exploration Rovers, you can clearly see that the engineers were inspired by the structure of Sojourner and took it as a basis for Spirit and Opportunity. They just took every part and made it better and bigger and revolutionized the system. A few things that were kept are the landing mechanism with a parachute and an airbag to soften the fall. Also, the solar arrays on the back were kept. They were just turned into little wings to increase the surface. Also, the rocker bogie suspension system the wheels were attached to was basically kept. The rovers had 6 individually steerable wheels. Also thanks to the rocker bogie system, they could pass a path with a lateral tilt of a maximum of 45 degrees. For safety, this was limited to 30 degrees. Roughly, the rovers consisted of a body, a mast with a total height of about 154 meters, and an instrument deployment arm here in the front. Of course, to increase the efficiency of the rovers, they had to be able to navigate autonomously. If the operators always had to give an order and then have to wait for the signal to travel, that would decrease the path the rovers can traverse every day by a lot if the safety of the rovers was to be guaranteed. So the rovers could be given a geological goal every day, then they would move there independently. They would use their pair of stereo navigation cameras mounted on the mast to take panoramic pictures of the surroundings. Those pictures would then be converted into a 3D model of the map of the surroundings, like you can see here. The map would be limited to about 10 × 10 meters across because little errors in the rover localization would make the map inaccurate if it was a lot bigger. The map was used to calculate the best path to the geological goal. This would be 1. The shortest, and 2, the safest path. The safety concerned things like the amount and size of the rubble in the way and the tilt. Also, we know the rovers would only tolerate a lateral tilt of 30 degrees, or else the IMU would give an alarm. The rover then would traverse 0.3 meters to 0.5 meters on this chosen path. Then it would stop for 20 seconds and reassess the situation. While static, it would take new pictures for the map and, for example, do the hazard avoidance. For the hazard avoidance, the rovers had HAZCAMs in the front and back. Spirit and Opportunity were expected to travel about 10 meters a day, like this. For comparison, Sojourner, their predecessor, traveled 100 meters in his entire lifetime. In the end, the Mars rovers ended up traveling 130 to 140 meters maximum in one day. In this lifetime, Opportunity traversed about 45 kilometers, which is the longest distance any rover has ever traveled on another body of our solar system, which is fantastic. One other thing that helped the navigation and localization a lot was the visual odometry used in the rovers. While Sojourner only used the amount its wheels had turned to calculate the distance traveled, the Mars Exploration Rovers also used their cameras to minimize the localization error. They took pictures before and after driving to determine the true distance between start and stop. This was necessary due to the rough terrain that makes wheels turn loose sometimes. The visual odometry reduced the localization error by a factor of 10. It also improved the hazard avoidance a lot, because this can only be achieved if the position of the rover in relation to the obstacles is well known. Now, to the instruments. Every day, Spirit and Opportunity would be active for about 4 hours, because that's how long the energy they got from their solar arrays lasted. They were supposed to find interesting rock formations on their path and analyze them. Interesting rocks are those which contain iron or iron-bearing minerals, or such that only form in the presence of liquid water. Also, rocks and soils that show signs of liquid abrasion are points of interest. To find those minerals, the MER had 2 instruments. First, the MINITES, or Thermal Emission Spectrometer. It was mounted on the mast and worked in the thermal infrared region of the spectrum. It is used to roughly determine the minerals in the surrounding rocks and soils and find interesting ones and determine the thermal properties for them. Also, when pointed upwards, the MINITES could measure the temperature profile of the Martian atmospheric boundary layer, which means the layer below the altitude of 10 kilometers. This is really useful because the orbiters before couldn't determine these profiles, as well as the rovers could do it. Second, the rovers had a pair of panoramic cameras on the mast. They had 13 filters each and were thus able to work multispectrally. The filters enabled pictures in different parts of the spectrum to, for example, increase contrast and estimate the mineral content of minerals. Like that, also the dust in the atmosphere could be analyzed. Also, in general, interesting looking rocks formations could be found. Also, by filtering the blue and infrared parts of the spectrum, direct pictures of the sun could be taken, and with that information, the orientation of the rover could be determined. The PanCam also had a kind of unique calibration target, which is really interesting. It included a sundial to determine the solar brightness and to be able to adjust it to it, and colors to adjust to the colors of the pictures. Once the rover has found a point of interest and driven up to it, it had an instrument deployment arm with tools to analyze the rocks and soils from up close. First, there is the RAT, the rock abrasion tool, at the tip, that brushed and grinded the upper layer of the rock to reveal a fresh layer to be analyzed by spectrometers. For that analysis, the rovers had 2 spectrometers. First, the APXS, which works in the alpha particle and X-ray spectrum. It was used for elemental analysis in general. Second, there was a Mills-Bauer spectrometer. This works in the gamma-ray spectrum and is used for iron-containing minerals. It could determine the amount of iron in a mineral and also the types of iron or the oxidation state of iron in the rocks. Also, the rovers had a magnetic array, several magnets to collect magnetic dust. Those are placed, for example, in the front of the PanCam, but also at the tip of the arm, so that the Mills-Bauer spectrometer could analyze it. Last of all, to look at the rock structures from up close and find signs of liquid abrasion, the rovers had a microscopic imager, an MI, which is a camera combined with a microscope. With that, small-scale features can be made visible and the undersurface of the rocks can be seen. So, now to the results of the missions. The rovers found numerous minerals that only form in the presence of liquid water, like hematite carbonate, and silicates. They also find signs of aqueous abrasion in rocks. They demonstrated that it is possible to safely land and operate sophisticated equipment on another planet for years. Also, they proved that we can send rovers to other planets and that can move around independently and adapt to changing and challenging conditions. The operators had to deal with failing parts, for example wheels and motors, software errors that sent Spirit into a day-long boot circle, dust storms, sand traps, rocks stuck in wheels, but they found ways to solve all these problems and keep the rovers alive. The operators learned how to adapt to those conditions and how to solve these kind of problems. However, after 6 years, Spirit died when it got stuck in a sand trap and could not be repositioned to get enough sunlight. Then, after almost 15 years, Opportunity got stuck in a sandstorm, probably could not recharge, and also lost connection to Earth. That may be the reason the Curiosity rover that followed these two was nuclear powered, so that it does not depend on the sun. It also enables a mission outside of the later equatorial regions. Operators like Perseverance can be seen here in the picture on the right side, and you can clearly see that. Operators use Spirit's and Opportunity's scientific work to inform Curiosity's traverse. For example, Curiosity can sense when it is in a sandy zone and is programmed to stop and ask its operators on Earth for help. The Robotic system was found good by the people, so it was used in Curiosity as well. As you can see in this picture, Curiosity on the right is also based on the Yar, but again bigger. Last of all, here's a short summary of the scientific results of the mission. One of the goals was to determine if life ever arose on Mars, or if the conditions there were once suitable for life to form. Opportunity discovered that the plains of Meridiani were once water-soaked, which is one of the basic conditions for life. It also found blueberries, so-called blueberries, little spheric rocks, which were found to consist mostly of hematite. Opportunity later also found jarosite, which only forms in the presence of acidic water. Jarosite is a mineral bearing iron and sulfur. This provided proof that at some point the water on Mars was acidic. Microbial life can also form in surroundings with acidic water. Also, finely layered ripples, crossbeds, and niches are found in the rocks where crystals once grew and were later redissolved. Another goal was to characterize the climate on Mars. Liquid water is not found on the surface of Mars today because the planet is too cold and the atmospheric pressure too low. So that water, if it is there on the surface, immediately boils away. Spirit and Opportunity measure the amount and distribution of dust and water ice in the Martian atmosphere. The rovers monitored changes in temperature at different heights above the surface and at different times of day over a span of a whole Martian year. The third goal was to characterize the geology on Mars. Especially rocks watered by water were searched and found. A map of minerals in the rocks and solids of Mars was made, and many pictures taken by the PanCams were sent back to Earth to be analyzed, which would take a long time because it were a lot of pictures. So this was my presentation.